Hi students, welcome to the problem solving session on Fourier Transform using properties. Let us see these problems. Find the Fourier Transform of the following function using properties. They are given 4 functions. Let us solve this. First problem is x of t is del of t minus 2. Right? So we have to use the properties to solve the problem. Right? So here time is delayed. So time shifting property of Fourier Transform we can use. We know del of t as a Fourier transform of what do you call 1. Yes or no? So this is x of t, this is x of omega. If x of t is x of omega as per the time shifting property, what is the formula? X of t minus t naught as a Fourier transform of e power minus j omega t naught into x of omega. So ours is del of t minus 2. So what we have to do, x of t is my del of t, for that x of omega is 1. So del of t as a x of omega of 1 multiplied by e power minus j omega. Instead of t naught we have 2. So 2. So Fourier transform of del of t minus 2 is e power minus j2 omega. Simple. Clear or not? What is x of t here? Here x of t is del of t. X of omega is 1. So del of t 1. So this is x of t minus t naught. Instead of t we have 2. Sorry, t naught we have 2. So instead of t naught substitute 2. What is x of omega? X of omega is 1. Substitute 1 over. The answer is very simple. Second problem, u of t minus 2. Second, x of t is equal to u of t minus 2. Follow the same procedure, right? If for x of t is u of t minus 2, they want us to find, right? We know for u of t, what is the Fourier transform? For u of t, Fourier transform is pi of del omega plus 1 by j omega. What we have to find, let us assume this is our x of t, for example. So here just for problem we have given, so we take x of t is u of t, this is x of omega. If x of t is u of t, x of omega is this one. What they asked, u of t minus 2, that is x of t minus 2. What will be the Fourier transform of x of t minus 2? E power minus j2 omega into x of omega. So x of omega, this one, as usual, pi into del of omega plus 1 by j omega multiplied by e power j2 omega. Simple, over. Are you understanding the logic? Right? So I take my equation u of t as x of t, for that x of omega. This is the Fourier transform. If x of t, let me take x of t minus 2 as u of t. So just leave it, no problem. It is very simple to understand. So u of t minus 2 as a Fourier transform of e power minus j2 omega pi of del omega into plus 1 by j omega. Simple problem. Third one is e power minus 2t u of t minus 3. Third problem, e power minus 2t u of t minus 3. Let us solve this problem in a critical way, because it is directly you cannot apply time shifting property. Why? Here also if we have a u of t minus 3, we can solve this problem directly. But here you see, here we have t minus 3, but here t only. Everything should be in terms of t minus 3 means we can solve. What is the formula we have? We know e power minus at u of t as a Fourier transform of, what do you call, 1 by a plus j omega. So if it is x of t, this must be x of omega. Clear? But what we have is e power minus 2t u of t minus 3. So everything should be in terms of e power minus 2t t minus 3 means we can solve, but here it is something different, so we have to manipulate the formula. How we are going to manipulate? I want t must be a t minus 3. So if I want t minus 3, what I need to do? E power minus 2t, I add plus 6 and minus 6. Clear or not? Why I am adding? Then only I will take 2 outside, then it will become t minus 3. Clear or not? So that's why I am adding like this. Into u of t minus 3. Okay, so now you see e power minus 6 I take separately, e power minus 6, e power minus 2 if I take outside, what I get is t minus 3 from these two. Clear or not? Into u of t minus 3. Now everything in terms of t minus 3. Now we can apply time shifting property. You understand why we cannot apply time shifting property directly here? Because it is separate, it is alone. Right? So here everything should be in terms of the same shifting. Then only we can apply the property. Right? So first you manipulate that and make sure that everything shifted in the same way. Otherwise you cannot apply the property. Now you see e power minus at u of t formula. Right? So we know for e power at u of t we have a formula Fourier transform of x of a 1 by a plus j omega. So this one is e power minus x is a constant and that we have to take every time. For constant we don't do anything. Okay, for this what is the Fourier transform? E power minus a, instead of a we have 2. So 1 divided that e power minus 6 I keep as it is, e power minus 6, 1 divided by, here we have a, right, plus j omega. If this is, it is nothing but x of t minus 3. This is x of t means it is x of t minus 3. I write here itself. X of t minus 3 will give Fourier transform of e power minus j3 omega into x of omega. Right? So this is my x of omega. That must be multiplied by e power minus j3 omega. That's it. Very simple. So if you simplify, what you have to do is, I take e power minus 3 outside in the numerator. What you get is 2 plus j omega divided by, so instead of a we have 2, so please put, I write properly, 2 plus j omega. This is what Fourier transform of the third problem. I hope you understand, right? Next, fourth problem. What do you call? E power minus t plus 2 u of t minus 2. Okay, so e power minus t plus 2 into u of t minus 2. Right? So I told everything should be shifted by the same time unit. So I write this one as e power minus, I take minus outside, t minus 2 u of t minus 2. Now it is paka. Yes or no? So everything in terms of e power minus t by 2. So if you have e power minus at u of t, what we get is 1 by a plus j omega. Let us assume this is x of t, this is x of omega. What we have is x of t, this is x of t means this is x of t shifted by 2 unit. Everywhere t is shifted by 2 unit. So x of t minus 2 is shifted by, as per the time shifting property, e power minus j2 omega into x of omega. Clear or not? So what is my, so Fourier transform of e power minus t minus 2 u of t minus 2 is given by e power minus j2 omega. X of omega is 1 by, here a is equal to 1, e power minus at. A is equal to 1. So 1 by 1, 1 plus j omega, right? Simple problem. This is the Fourier transform of the third problem, right? So I hope you understand this concept. If you have any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.